All right, guys. Sorry, I taught this whole lesson without hitting record the first time. So take two, maybe it'll turn out slightly neater, given the fact that I just did this 10 minutes ago or less, means that there's sometimes I'll think I already said something because I did say it before just when I didn't record it. So if there's something that you feel like is missing or something unclear, as always, let me know. So in this lesson, we're going to look at adding vectors that aren't at right angles. So first of all, just a quick reminder, tail of the vector is the non-arrow end. The head of the vector is where the arrow ends. The direction is always given as an angle. For anything that we do, it's always going to be given as an angle. We're not going to deal with surveying directions. And the magnitude is the length of the vector. To give an answer in a vector question, magnitude and direction are both required, even if both are not specifically stated. So if I ask you what's the sum of the vectors, you need to have magnitude and direction, even if I don't specifically state magnitude and direction. I will often ask for both, just as a memory jogger, but you do need both components. It's essential. It's not a vector if it doesn't have both. So the first thing we're going to need to know how to do in this lesson is we need to know how to resolve vectors into components. So what we want to do is we want to take a vector that's not perfectly on the x-axis or perfectly on the y-axis, and we want to break it apart into two vectors that could add to the same vector that have an x and y component. So basically what we want to find is I want to find out at this point right here at the tip of the vector, what is the x and what is the y? Now, in order to find that, if we look at a Cartesian coordinate system, our y is how much vertical we've gone up, and our x is how much horizontal we're over. Now that I've sketched those in, you can probably see we have a right angle triangle. So we're going to use right angle trigonometry for this. Our y side is going to be opposite. X is going to be adjacent. And of course, this would be our hypotenuse. Okay, so those are our vectors, or our x and our y. So we just want, when I want you to calculate the components, I just want you to tell me what is the x and what is the y. So using trig, let's find x first. I usually always find x first because I draw x first. X. Well, in order to find x, it's adjacent and hypotenuse. So let's think about SOHCAHTOA. Adjacent uses cosine. So x is going to be cosine of whatever angle we have is going to be equal to x over, and instead of hypotenuse, I'm going to say v for vector length. Okay, so I'll call it vector length. So that's easy enough to figure out. We can rearrange it quite simply. If I want to know x, x is going to be the length of the vector times the cosine of our angle. Now, this is a convenient way to memorize it because we can use this in every single situation, given a couple of rules. We'll talk about those rules in a moment. So length of our vector is 15 times the cosine of 28 gives us 13.2 meters. And 1 decimal place is perfectly sufficient for this question. So there is our x value. We could put 13.2 in for x there. If we want to know the y value, well, y is the opposite side. So to use opposite, use a sine. So the sine of an angle is equal to y over the vector length. Or we can say y is equal to the vector length times the sine of the angle. Plugging in our information again, 15 sine 28, we get a vector length of 7.0. So we could say our components, our x component is 13.2 and our y component is 7.0. And had I given you those two components last lesson, you could have added them together and the vector that you would have got would have been 15 meters at 28 degrees. So what we're doing is we're just breaking the two vectors into parts. Because when we add two vectors together, if we can add the x pieces together as parallel vectors, that's easy. If we can add the y pieces together as parallel pieces, that's pretty easy. And we know how to take an x and a y and add them together. But we don't know, I haven't done the cosine law with you because it's complicated and nobody does it in trades. You learn it in grade 11 math, but in the trades, we don't use it. So because it gets complicated if there's more than two vectors. It doesn't work for when you have three vectors, which you're going to need to know for electrical. So that's why we're breaking things into components. All right, let's break this one into component. Now this one, it's a little trickier to see which one's sine and which one's cosine. You'll notice our triangle isn't in this first quadrant. You have 124 degrees. You can't draw a right angle triangle with 124 degrees. So what do? Well, if we take the math from our first section and we take this particular equation, we can use it in every single situation so long as that angle is referenced from 0. Oops. So we just discovered in our last lesson using the first quadrant, we found out that the y component is sine and the x component uses cosine. So we know that x is equal to the length of the vector times this, whoops, I always want to put them around when I go to write them. I want to write sine first because of the order of SOHCAHTOA. Vector times the cosine of our angle. Y is equal to the length of the vector times the sine of the angle. To use these, the angle must be measured from 0. Okay, so we have to measure from the 0 degree line. If we haven't measured from the 0 degree line, you're going to have to correct it to be from 0, and then you can use these formulas always. Otherwise, break down your trig, but make sure you label it to figure out should it be sine or cosine, because they could flip depending on where you put your angle. All right, so if you want to use this rule, we're going to convert all of our angles to be from 0, and we'll quickly calculate them using in a couple of examples. So to figure out our components, the x component in this case is going to be 18 times cosine of 124. Now you'll notice this arrow points, vector points in the negative x direction. So if I was putting signs, guessing what the answer should be, I know that x should be negative and y should be positive. Let's see what you get when you calculate. If you put this into your calculator, you will find that you get negative 10.1. It comes out negative already in your calculator. That is correct. It matches with the right quadrant. Y should be positive. So 18 times the sine of 124 is equal to 14.9 meters. It's positive as you would expect. Pretty straightforward. It's not complicated to do vectors into components. I am going to give you 2 more of them just because these ones deal with correcting the angles, and I want to make sure you can correct your angle. I'm sure you can calculate the sine of the x and y components, but correcting the angle is something that a few people struggled with or had questions about in our last lesson. And I appreciate those questions, so thanks for sending them through. So vector B here, we have 30 degrees, but you'll notice the 0 degree line is here. This is the 90 degree line. Okay, so it's not referenced from 0, it's referenced from 90, so we need to correct it. So if this is 90 and I go back 30, that must mean that this angle is 90 minus 30, which is 60. So if I recalculate it and I say, well, this is 20 meters at 60 degrees, measuring it from 0, now we can use those formulas that we had where x is equal to the length of the vector, 20, times the cosine of 60, and we'll find that that vector, the x component has a length of 10 meters, and the y component is going to be equal to 20 sine 60. Now you will find if you didn't change those, if you didn't correct the angle, you would get exactly the opposite of what you should. I want you to think about why that would happen. See if you come up with a reason for it. let's just think for a sec. If we drew this triangle and you have 30 here, well, if we drew the triangle that way, we would have opposite and adjacent. That would make x equal to opposite and y equal to adjacent. So it flips the opposite and adjacent. That's why you would get them in different places if you used these memorized formulas without correcting your angle. Okay, so that's one of those things that can happen, and it's hard to watch for it in the middle. So always stop and correct your angle to be from 0, because Andy's going to ask you to correct your angles to be from 0 as well. That's one of the standards for electrical. All right, one more really quickly. I mostly want to get the angle from it, and I'll give you the length of, and I think we'll just leave calculating the length of the components until we use it in one of our future questions. So in this particular question, the angle from 0 is what? So there's 0 degrees. I want to know what is the red angle. So think about, now we have 90, 180, and then 270. So the red partial circle, the red angle that I have highlighted here is 270 minus 25 degrees. I'm just thinking about how close am I to that? What would it take to get there? And that gives us 245 degrees. So that's our corrected angle. Make sense? If that doesn't make sense to you, please check in with me. Ask a question. Usually it's really simple, but just kind of sketching it out and thinking, okay, what are the 4 quadrants equal to? What are each line equal to? And where does my triangle fit within that diagram? We'll figure out our components for this one in one of our examples, because I'm going to give that to you again anyway, but I just wanted to go through correcting the angles a couple times. All right, so to start, we're going to add 2 vectors that are non-right angle vectors. So if we put these 2 vectors together, we definitely do not have a right angle between them. If we were to kind of do a little rough sketch, we have vector A going this way, and then to the tip of that, we're going to add vector B, and it goes off in the positive direction some more. So that's vector A, this is vector B, and we'll have a resultant somewheres over here, but we definitely don't have a right angle, no matter which way we look at it. But you know how to add right angle vectors. So we're going to break this vector apart into a right angle vector, because if we could, actually, let me just erase that line and switch a pen color here. See if I can do make a couple of these look a little prettier for us. All right. So our resultant, I'll sketch here. This is our resultant vector, so that would be the sum. And I'm going to just take a green pen here. Actually, I'll take a different color pen, just in case somebody's red-green colorblind. We'll take a blue. Hopefully that works out okay. We'll take blue, and we'll say, you know, if I knew the total x and the total y, I could find out what the resultant is using my right angle vector. So what we're going to do is, if we know the x for A and I know the x for B, we'll add them together. So we're going to use our component method in order to calculate that. So that's why we needed to know how to figure out components. So remember, for your x component, remember your formula. Your formula for the x component is x is equal to the length of the vector times the cosine of our angle. Little memory trick. I don't know if I just noticed that this year or if I've noticed it before. X and Y are alphabetical order. X first, then Y. Cosine goes with X. C is first in the alphabet. Y goes with sine. S is second in the alphabet. If you need a way to memorize it, since I'm not going to give you the formula and you don't want to draw a triangle, that works. So Y is going to be equal to the vector length times the sine of the angle. I use little tricks like that all the time. That's the only way I survived school. So I don't have any special powers. It's just those little things that you remember. All right, now let's calculate our vector here. I've got everything written down, so it won't take me too long to put the numbers in, but you probably want to, if I'm going too quickly, pause, pop it in your calculator, make sure you're getting the same values. If you can't put it in your calculator, it means you're not going to get it right on the test. So do make sure you can calculate it as well. So our x component for vector A is 15 meters times the cosine of 28. The angle here is already from 0, so we don't have to change it. We get 13.224 for the length of the vector. I've kept extra decimals when I was calculating these, so I'm going to leave them just because it may impact rounding in what I've written for a final answer. You should be very close. Y, I'm going to do the same thing, 15 times the sine of 28 degrees. And we get 7.04. Both of them are positive, but we would expect to get positive and positive in the first quadrant. That's normal. For vector B, we should also get positive and positive. We've already looked at vector B before, and we've said vector B is not measured from 0, so we need to correct the angle, and we need to use this angle here, which is 60 degrees. All right, so we're going to calculate that, but we're going to use the 60. So it's going to be 20 times the cosine of 60, which gives us 10, and then 20 times the sine of 60, which gives us 17.32. Now we take each of our components. So I'm taking the circle numbers, and I'm going to add the two x's together because it's going in the positive x plus a little more in the positive x. Adding those together, we get 23.24. For the y direction, same thing. Add the two of them together, and we're going to get 24.36 meters. So now we know what the length of our blue lines are, which makes it very easy for us to draw to calculate this vector addition. Now I'm going to redraw the vector. I'm going to draw my x, and I'm going to draw my y, just because this will give us a little less information in the middle, and there's our resultant. So our x was 23.24, and our y is 24.36, and there's our angle. So the length of the resultant is equal to, well, you have to do a squared plus b squared equals c squared, so the resultant squared is going to be 23.24 squared plus 24.36 squared, which gives us 1,133.51. Take the square root, and the resultant is equal to 33.7 meters. So that's the length of our vector. It's not quite our final answer, but it's the length of the vector. So that's our size. Direction, we'll calculate over here. Now direction, remember from last lesson, we used tangent. So I want to find there's my angle. The tan of the angle is equal to opposite, 24.36, over adjacent, which is 23.24. The angle that you calculate, and I'm assuming you know how to rearrange this at this point without me showing all of the in-between steps, the angle that you get is going to be 46.3 or 46 degrees. So the sum vector, or the resultant, is equal to 33.7 meters at 46 degrees. We do not have to do any correction here because you'll notice this angle is already measured from 0 degrees. So you don't have to adjust anything. You can give the answer exactly as you have calculated it. One advantage to writing this twice is I know how much space I happen to have, and it's coming out slightly neater and hopefully a little easier for you. And I think it might be going a little bit faster too. So there may be some bonuses here. All right, one more vector question. This is the last one I'm going to do, and then I'm going to give you a chart of steps that you can follow while you do your assignment. So add vectors C and vectors F, give the magnitude and the direction of the resultant. So same steps as before. Now this particular one, if we think of it like a tug of war, maybe, you're pulling both towards the left, but one person's pulling upwards and one person's pulling downwards. So those up and down forces should kind of cancel out a little bit, and you're going to pull closer to straight, and then, but it's still going to be all towards the left. So if we were to do kind of a tip to tail sketch, there's vector C, and the person F, vector F, would be somewheres off in this direction. And we're not sure where it's going to land above or below this axis, but it's going to be somewheres over there. So our resultant's going to be something like this. Okay, when we add them all together. I always like to know, what should my answer be? What direction should it be pointing? And I know it should be pointing, the sum is going to be more towards the left-hand side. Just helps me in checking my work and making sure I've got positives and negatives in the right places, because I know I flip those around. So I use extra tools to check and see, can I figure it out? So for vector, well, instead I got A and B here still, let's change these up. We'll call vector C and vector F. So for vector C, we're going to start with 18 times x goes with cosine. It's the cosine of 124, and then 18 times the sine of 124. If you calculate those, you're going to get negative 10.1. Well, this vector here, it is pointing in the negative x and positive y direction, so that makes sense. And then we get 14.9 for our y direction, positive y. This vector is pointing in the negative x and the negative y direction. So we should get two negative answers here. But we have 25 degrees. If you put 25 degrees, you're going to get positive x and positive y. That's going to tell you, oh, I should check, do I have the right angle? We already calculated this angle before. From 0 degrees, we're 270 minus 25. Leaves us with 245 degrees. So for this vector, we're going to use 23 times the cosine of 245. And then here we're going to do 23 times the sine of 245. And that's going to give us negative 9.7 and negative 20.8. Negative x and negative y means we put the right angle in. It's matching what works graphically as well. So we're using pictures and math to work together. Much like if you remember when you were learning how to read, you would use the picture to go with the words, and sometimes use the pictures more than the words, so you didn't necessarily read the whole story. My brother got through a lot of school without being able to read just because he could figure it out from the pictures. Use the pictures in this case to help you out. It's a good tool. It's a strategy that you don't lose as you get older. You keep using it. Now we want to add them together. So in the x direction, so pulling this way, we notice it's more towards the x than either vector C or vector F. So we're going to add these two together. So adding them together, we get 19.8 negative. Two negatives gets more negative. Y component, we have 14.9 positive, 20.8 negative. You can think about adding them together. You can think about subtracting them, whichever way works for you. In your calculator, if you put 14.9 plus negative 20.8, you will get negative 5.9. So you still have more negatives left over. So some of the positive pull cancels, but the negative wins. So you get more negative. Now we're going to do the same thing as we did before. We're going to first draw. Maybe I shouldn't call that first. I should call this first, our table. I'm going to do a little bit of erasing here. I will go back for a pen. So this is 1 and 2 on the steps that I'm going to give you next. So 1 and 2 is break into components and sum them together. Step 3 is draw it, and we're going to draw our x first. So we're going to start here because we got to go negative x. So this is negative 19.8. Then we're going to go negative 5.9. You'll notice I draw it shorter just because that helps with my, it just helps me visualize what's happening. So negative 5.9. And we want to find out what is the resultant. 4. we're going to find the magnitude. So to find the magnitude, we're going to use Pythagorean theorem. The resultant squared is equal to negative 19.8 squared plus negative 5.9 squared. Adding those two together, we're going to get r squared is equal to 426.85. Take the square root of both sides. R is equal to 20.7. So that's the length of our vector. Now we need step 5 is direction. And to find the direction, we're going to use the tan of our angle is equal to tan is opposite, so negative 5.9 over adjacent, which is negative 19.8. The angle is equal to 17 degrees. Now we have to stop. Do we need to correct the angle? The answer is yes. We are not in the first quadrant. Secondly, we're not measuring from 0 because to go from 0, we have to go all the way around. So we need to go 180 plus our angle. So we're going to correct 180 plus 17 gives us 197. So the answer, final answer, we'll put it all together, all the little bits. 20.7 meters is the length at 197 degrees. Okay? And that's your final solution. So you put everything together, but in this case, we had to correct the angle, and you can use that 180 plus the 17. So using your picture to help you draw. If you have any questions about that, please let me know. This is something Andy's going to expect you to know how to do. So in order to help you out, I've given you just kind of a little cheat guide. You will not be allowed this on the test. I'm sorry. This is something you have to have memorized, especially because Andy's going to use it when you do 3-phase vector addition. I'm going to give you a video where we add 3 vectors. I'll do one example with 3 vectors, and you may see a 3-vector example on a test. With the 3 vectors, we're just going to follow exactly the same steps, except we have to do the components of one more vector. First, break into components. Sum the components, draw the vector, find the size, and then find the direction. So 5 pretty simple steps. None of them are too complicated. It seemed way more complicated when I learned this in high school than it is when we go through it now. So please let me know if you have any trouble, but I think you're going to be fine.